Good afternoon, everyone. Today we are going to talk about streams. Just one short announcement, I'll talk about it later too. So as per the calendar, next week will be mid-sem exam, okay? So there will not be lecture, but I will tell the timeline. It's very likely to be the same as assignment. I'm not planning to change it, but so announcement will be made midweek. By Wednesday, we'll make the announcement. Okay. So the only difference is the weight will be very high. So I request all of you to consider it fairly seriously. Okay. So yeah, compared to assignments, assignment is only 5%, whereas mid-sem it will be 25%. There will also be Viva over the week. It will be similar to the Vivas, but I will also be participating, not just the TAs. Okay. Okay. So today we will quickly review the stream facilities in our input-output streams in C++. We have been using it all through. So we'll just discuss a bit. Yeah. So before the mid-sem, we'll release everything. Okay. Yeah. So Mata Mittal, the lab marks will release before the mid-sem. Okay. Yeah. Okay. So we'll just see certain slight difference from how it is done in C. I mean, it's not completely different though. I mean, it borrows the same concept of streams from C. I mean, in C, input output are seen as streams. That is basically a stream of characters. Okay. Yeah. So we have already used C in and C out. So these are parts of objects or classes called input and output stream. Okay, so just let's see, how do I get the highlighter? Okay, sorry. Okay, so I stream represents the input stream. Okay, whereas O stream represents the output stream. So by default, for any program, Cin is an object of type iStream. It's always declared, and similarly, Cout is an object of type OStream. Okay, so they are always available. So that's what we did in our programs. Okay, so only thing is, if you don't use this line where you say using namespace std, so you will have to have this std prefix. Okay, so this is, they are defined in the standard namespace. Okay, so cout is an object of outstream. So basically whatever you want to output, you want to redirect. So this operator is what allows us to transfer data to the stream. Similarly, this is to transfer data from the stream into the object. Okay, so these are overloaded operators. We have already seen how to overload these operators to our own classes as such. Yeah, in general, this is actually the left shift operator, but it is overloaded to indicate. So with the stream objects, they are overloaded to indicate transfer of data. Okay, so you can overload multiple in the sense that so cout with this operator will always return cout, a pointer to cout. So you can overload it further. Okay, so similarly cin, it's the same thing. It returns the object pointer to the same object. Okay, so that way multiple in the same line is allowed. So one thing that we need to remember is cin and cout are not classes, they are objects. Okay, so objects of type iStream and OStream. Okay. Yeah, so we'll see about certain aspects here. So stream is nothing but, I mean, simple terms, stream is nothing but a string. Okay, so a flow of characters. Okay, so you have a start pointer. One thing that C++ does is by default, it reads white space separated tokens or strings, I would say. Okay, so white space is a separator in C++. This is also true in C as well. Okay, So let's just take an example and demonstrate its features or limitations. So let's assume our stream contains this data. So 1, 2 followed by blank space, 1, 7.3 blank space, minus 1, 9. Okay. So there are 4 different segments, okay, which basically read data from this stream. Okay. So here A and B are int variables and X is double variable. So we say C in A, what it does is so the stream will be at the beginning, the pointer will be at the beginning. Okay. So it will read until it finds a white space. Okay. 1, 2. So A will get a value of 1, 2. So now X is a double type, so it will look for data of double type. So that is some number followed by a decimal point followed by some number. Okay. So what I get here will be 17.3. Of course, similar to C, you can also change the format. Okay. So OX would start for octal format and so on. But without any additional feature, I mean, it will just see it as a decimal number. Okay. And B is of int type, so it will ignore this white space after whatever is available. So minus 19 is a valid integer, so it will read into that. Okay. Now, so let's change this slightly. So let's assume X is of character type. Okay, and A and B are integer as it is here. Okay, so you first read A, I'll get 12. But now next I'm reading B, which is of integer type, but the data available here is 17.3, but a dot is something not allowed in integer type, right? It's not valid for integer. So 17.3 is not a valid integer. So what this does is it will just read 17 and leave the pointer at that place. So I'll just cut the call. Sorry. Okay, so 17 will be read into B, and then X is a character, so X will read point. Okay. Now if I read into an integer variable once again, whatever is left over as integer before again the white space or separation, see here any invalid character will be seen as a separator. Okay. So in this case point for integers. So whereas for character it is valid, so point will be read. Okay, dot will be read. Similarly for A, it will read the next portion which represents integer. So after 3 there is a blank space, so it will read as white space, it will read as 3. Okay. So now slight modification. So let A only be integer and B, C, D are characters. Let's see how it reads. So A, the first integer value, A will get 12. Okay, and then there is a blank space, it will ignore blank space. Okay, so then the next character will be 1, so B will get 1, C will get 7. Okay, if I had read D, D will get point. Okay, so it reads character by character, ignoring white spaces. Okay, so if I had put multiple white spaces here, it will ignore that as well. Now when you do string, so this tokenizes into 3 strings. Okay, so 12 separated by white space is a separator, remember. 17.3 is a string, then again white space, minus 19 is a string. So if I declare ABC as string, so remember string is a class which we didn't discuss, we'll discuss soon. You can imagine it's a class which manages strings. Okay, so instead of declaring character arrays for representing strings, so C++ in fact has a class string. It or in fact implements it as a dynamic array, but nevertheless. Okay, so you can just imagine this holds strings. Okay, so now if I want to read the first string, it will be 12, and then again to B I'll get 17.3, to C I'll get minus 19. Okay, so character is blindly character, but only thing is it will be ignoring white spaces. Okay, so this token is a term which basically originating from compilers. Okay, so we don't have to bother about it. So token is basically, if you put a separator, right, whatever, so if you have a data, you can just imagine it as a string. Now if suppose I say blank space is a separator, okay, So token is what I get after putting this separator. So 12 is a token here, 17.3 is a token, minus 19 is a token. But this token depends on the data type. So this is a valid token with respect to integer and double data type. Okay, so this is valid for double data type. For integer data type, dot is seen as a separator, but dot is not a valid data type. So for integer type, I'll get 12, 17, 3, minus 19. But however, if I try to read integers, right, after 17, if I try to read integer, it will in fact set, so I say x was integer, and if I try to read x here, it will set as 0, because dot is not a valid data for integer. Okay, so it will give an error. It will not show error, but there we'll see how to check that error later. Okay. Yeah, so this kind of demonstrates how Cin works. This is something that we need to be careful about. I'm sure most of you have already experienced it while implementing the assignments. Okay, so at input, I mean C++ by default, that's what it does. It's very similar to how it is done in C. So similar to white space, new line will also be a separator. Okay, new line will also be treated as a separator. Okay. So you might have seen those who have implemented C, there is this seek operation. Okay, so seek operation basically allows you to jump, so ignore certain input. Okay, so for example, after reading 12 here, if I want to say jump some 4 to 5 characters, right, I can do that as well using the ignore functionality in Cin class or object. Okay. In C, this is something called seek operator. Okay, it allows you to move the pointer. So you can imagine there is a pointer here at the beginning, and the pointer moves as and when you read. So after you read 12, the pointer will be here, but this is a separator, so in fact the pointer will be here. Okay, so after reading say 17, you read only integer, then the pointer will be here. If you are not reading character, this pointer will be shifted, but this value will be discarded. If you are reading a cat or string, so if it is string, what will be the data that you will get? 0.3 from here. Okay, so yeah, so pointer, when I say pointer, you can just imagine the physical pointer. Okay, so let's not worry about water pointers from C and so on. It's essentially that, I mean, related, but yeah, you can just imagine it this way. Okay, or head, you can just say head. Okay, so one thing Cin does is it ignores leading white space. Okay, so this is something that we should always keep in mind. It won't read white space. Okay, it's not designed to read white space. So we'll see how to overcome that. I mean, using the getLine functionality. Okay. So yeah, so this functionality that I said, if you want to jump, you can have this function called ignore. So which is part of iStream. So Cin is an object of iStream. Okay. So this basically says skip until n positions, or skip up to n characters from where you are currently, or until the character is seen. Okay. So for example, if you want to ignore until a line, right, you can just say skip until new line. Okay. So for example, so there are two examples here. So let's say so what is entered is, let's say, ABCD. Okay, so we say Cin dot ignore 2 with the character A. Okay, so it ignores until A is seen or 2 characters. Okay, whichever is earlier. So now A is seen here, so it ignores. So what it reads will be BCD. Okay, so when you say Cin name, what will be read will be BCD. So the output will be BCD here. Okay, so the other example where the character is not seen, but you will jump n characters. Okay, so Cin ignore 2, but say, let's say instead of A we gave Z here, so Z was not seen here. So by default what it does is it jumps 2 characters. So to name, what we get will be CD. So the output will be CD here. Okay. Yeah, so this is one feature, it's helpful many a times, okay, particularly like I said, so if you want to ignore new line, okay, so new line is usually represented in this. I mean, it's the same as what it is in C. Now, C out is again a stream, okay, so when I say stream, it's basically a flow, okay, so you'll have a stream of characters. So one thing that C as well as C++ does is it follows a buffered output model, okay. So buffer will be some memory area. So you will know about buffers much more when you learn operating systems, if at all you plan to do that course, okay, or yeah, so when you learn compilers, okay. So what it does is it won't output. So your program, right? It's the same in C as well. Okay. So as you output, it's not immediately redirected to the screen. Okay. So the reason being at those times, right, when these programming languages were developed, uh, so outputting to the screen itself was a costly operation. It could be time consuming, okay, writing to the display. Nowadays we have graphic processor units and so on, it's much faster. I mean, writing a character won't take even a fraction of microseconds, okay. Whereas the time when these programming languages are designed, displaying, right? So we used to have CRT screens, big CRT screens, very heavy ones. It takes some time, okay. I mean, even a microsecond is too much for a processor, right? If you want to run, say, so if you're looking at processors with a clock speed of gigahertz, right? So they will be doing much more than million instructions per second. Okay, so that way, or even hundreds of instructions per second, hundreds of millions of instructions per second. So in that case, even a microsecond is a delay. Okay, so in such, I mean, particularly to take care of that, most of the programming language, they are designed to handle output in a buffered fashion. Okay, so it will not print to the screen immediately. Okay, so to force print, you will have to use flush. If you remember, there was this flush function in C as well, f flush. Okay, so only when, so when I say enter your name, it will not flush, but since you are asking for C name, right, it would have. Okay, so you cannot say when it will flush and so on. So I mean, well, there are some rules to it, but you can always force it to flush, saying okay, C out flush. Or you can also use this for new line, end line, or ENDL is the word for it. Okay, so instead of using /n within uh, quotes, you can use endl. It automatically flushes. Okay, so this is again one feature, I mean, something that we need to keep in mind, but in most of the cases it is not even noticeable. Okay, so this time for flush is not even noticeable, but it can happen that so earlier times, I mean, like I said, right, this output is, I mean, displaying something on a screen would be time consuming. So there is a deferment. Okay, so when the buffer is full, it will flush, or there is an event. So for example, in this case, you're done with this command, but so you're going to read something from the input. So usually it will flush. Okay, so that is something that we need to know. I mean, it's like I said, it won't affect us much. Okay. Okay, so I'll quickly jump to a different slide for now. Okay, come back. So there are some more issues that I wanted to discuss. Yeah, so this is what we have seen. The I stream, O stream, C in and C out are the objects. So the operators are overloaded. Okay, so you can also overload. So we have seen how to overload these operators for outputting values corresponding to your class object. Okay. Yeah. So this is a summary, okay, of different streams. So one advantage, I mean, this is essentially borrowed from C, is you treat reading from input output devices, or reading from a file, or reading from a string in a similar fashion in C++. Okay. So here the classes are iStream, OStream, IOStream. Now there is something here. Let's ignore for a second now. Okay. So iStream is for input from a stream. OStream is write to a stream. IOStream is for read and write. Okay. So you may want to have the same object. So typically it is advised not to have the same object for reading and writing. Okay, so that is why in standard practice we have cin and cout, but in some scenarios you may want to have the similar same pointer. So then in that case you have this derived class IOStream. It is essentially derived from iStream and OStream. Okay, so this W, so here see what is the character length. So I said from the stream you will be essentially reading character by character. Depending on the data type, the separator will be designed. Okay, so typically the characters are 8 bits long. Okay, so but if you want wider, that is 16 bits, so then you have to use the stream objects with the W prefix. So W iStream for wide characters, this is for wide characters, this is for wide characters. So particularly if you want to use some other fonts and so on, right, you might need wider character, larger characters. Okay, so again this is the extended ASCII format. So but we can ignore it for now. Just for completeness I have just included. I borrowed this from C++ primer book. Okay, so I just copied the table. Now similar to IOStream, we can also define file streams. Okay, so for file stream again the 3 classes are there. If if stream, that is input file stream, this is for output file stream, and again for read write you can just have f stream. We'll see how it is done in the next slide, okay, or very soon. And similarly for string you can also have string as a stream. See, of course what I said is a stream is nothing but a flow of strings. So if you have a string, you can see it as a stream as well. Okay, so the corresponding classes here are iString stream, OString stream, and string stream. So this is usually helpful. See, one limitation with IOStream is it uses white spaces as separators. Okay, so when you take data, when you read data using the usual cout or read data using cin with operator overload, operator whatever the right shift. So the problem would be you will have to, you won't know how many white spaces there. Okay, so for that one way to go about is cin also supports this get line. Okay, so it reads whatever is available as a string until a new line is seen. Okay, so in that case you can just see that string as a stream and then process using the same standard input output functionalities. Okay, so particularly string stream is useful when you are reading a line, okay, or processing a line. Yeah, so one thing to note is, so this is something important so that you won't run into an error. So these stream objects, right, output stream or input stream or whatever, you cannot assign one to another. Okay, so say cin cannot be assigned to something or something cannot be assigned to cin. Okay, so you cannot assign stream objects, so that is forbidden here. Okay, yeah, so I want to discuss. So there are certain things, certain time amount of a point of time you may want to know what happened. So for example, like I said here, right, so when the input pointer, so let me slide. Yeah, so when the input pointer is here, right, so if you are reading an int, so I said you will get value 0. Okay, but suddenly you might have gotten 0. You want to know whether the user had entered 0 or something had gone wrong. So this can be checked using status of the stream, okay, by looking at status of the stream. Okay, so the standard implementation is when I say cin some variable, okay, so this returns a boolean value as such. Okay, so what it does is, of course it also returns a pointer, but I can use this, say while cin where some function here. So this will run as long as there is no error in cin. As long as it reads a valid value, this is going to run. Okay. But the problem is, so cin var could be false for various reasons. It could be invalid input, like I said, you had a dot at the pointer, but you are reading an integer, or it could be end of the file, or a new line, or it could be some other reason. The file may not be readable, whatever. Okay. So I mean, it's not a variable. Sorry, this is a wrong term I have used. So all these stream classes, they're derived from, so they has IO state as a base class. Okay, IO state has 4 attributes. I'll talk about it in the next slide. So we can use the variables corresponding to the class IO state, which is a part of IO base, iOS base in iOS underscore base, which is what all these streams are derived from. To know the status, what is the current status of the stream. Okay, so again I have copy pasted the table from the C++ primer book. So IO state has 4 bits here. Okay, so good bit, end of file bit, EOF bit, fail bit, and bad bit. They are accessible to outside program. They are public variables. So good bit, if good bit is set to true, it indicates that there is no error. If good bit is set to false, then it indicates that there is an error. Okay. So IO state also allows functionalities which can be accessed to the stream objects. So good is a function which indicates if the good bit is true or not. End of file to indicate whether end of file bit is true or not. Similarly, fail, bad, and this would be basically talking about state which, so it basically will give you which variable is true, either good bit or end of file bit or fail bit or bad bit. Okay. Yeah, so good bit basically, so for example, if I had dot, but I'm reading an integer, so the current pointer pointing to dot or some other ASCII character, say dollar symbol, but I'm reading an integer, then good will become false. Okay, so then the data read is not good. Okay, so end of file is if you are reading, but if no more input is available. So some of you might have tried, right? So when you input data, have you tried typing Control D? Sorry. Okay, sorry, I missed a question. Shiva Subramanian. Yeah, so that is what we are planning. Okay, so I'll make the announcement on Wednesday. There might be a slightly shorter because this mid-sem will be a shorter question. Okay, so it won't be as lengthy as as assignment, but it will be more personalized. So we'll discuss and get back to you on Wednesday. Okay, so as of now, yeah, so Control plus C ends the process. But have you tried Control D? So Control D is basically end of file. Okay, so it will indicate that, see, so what essentially iStream or OStream they do is they treat these as files. Okay, so iStream basically sees standard in as file. The moment you type Control D in Linux, in a Linux environment, it tells the system that okay, this is end of file. So that means file has ended. So then your program will get into trouble if it wants to read more data. Okay, so this bit basically indicates if it's end of file. So for example, if you are reading from a file, right? So end of file is when it reaches the end of the file, the bit will be set to true. Okay, so all other bits will be irrelevant here. Sorry. So fail bit is for other logical errors. Okay, so in an IO operation, it may not be maybe unable to open the file or access the file or whatever. Okay, or our input device might be malfunctioning or whatever. So in that case, the fail function will return true. Okay, so bad bit is basically read writing error on the IO operation. Okay, so this could be the data is being bad or whatever. Okay, So here fail as well as bad will be true. Okay. So the RD state value will be bad bit. Okay. Yeah, so this fail could be something due to the system error, whereas these three things could be bad for the, this could be because of the input. Okay, end of file could also be, end of file is of course end of the file, so it just indicates that you cannot get any more input as such. Yeah, so we need to remember it, particularly when you implement programs later on, large programs, when you process files and so on. These things are going to be useful. Okay. Yeah. So maybe I'll switch the slide, talk about files. Okay. Okay. So a very similar fashion to how to how we deal with input and output stream, we are also allowed to handle files as streams. Okay. So the library is fstream, which provides us routines which handle files. So the objects for input from reading from a file is if stream, input file stream. This is for output file stream. Okay. So here there is an example. So again, the namespace is standard for all file input output. Okay. So one thing is, so to read, so to open a file in the read mode, what we do is we say if stream file name. So object name. So object name is going to be file here. So you give the file name as a parameter, which will be a string. Okay. So assuming that you have stored some file with name stream4.cpp, for example, this file itself. Okay. Then the file variable will contain a pointer to the stream which gives access to the content of stream4.cpp. That is basically this program itself. Okay. Let's say we have a string class with the name word. Okay. So let's say until the, so this basically reads as until the end of file, you do this operation. You read a word from the file and then display it in the standard screen or standard display. And this is the close operation, as you might have seen in C. Those who are familiar with C, if open a file, you need to close it. Okay. But in C++, it's not necessary, but it's a good practice to have it. Okay. So by default, it does. So the destructor actually has this close operation. Okay. So let's just see what has happened here. Okay. Sorry. So if you run this program, compile and run this program, assuming that stream.4.cpp has this data written in it. Okay. So your output will look like this: hash include iostream, hash include fstream, using namespace and so on. So you can see something gone bad, right? So it's not exactly the same content. So the reason being, when you read something, the separation characters are suppressed. Okay. So here there is a new line, here there is a space, here there is no space here. Here there is a space, here there is a space. All of these are suppressed. Here there is a new line that is suppressed. This is suppressed. This is suppressed. So if it just writes by removing all those separation characters, white space and new line. Okay. In this case, everything else is written as such. So that is one limitation. For that, you will have to do something. Okay. So we'll see how to do that. Okay. But apart from that, this also has a problem here. Okay. So if you do it this way, so here the closing parenthesis or closing curly brace, it's repeated twice. Okay. So so that is basically due to this condition that we have put. Okay. So the last time when you would have read, sorry, okay, so okay, so after this new line, you would have read this. Okay. So the file may not be just still end of file. Okay. After you read it, so yeah, so what will happen is, yeah, so this essentially, so after you read this curly brace, right? Okay. So what you will have is end of file, okay, but this will not still be end of file when you read curly brace. So what it will do is, so this one will return error in the sense that it will not change the content of word. The content of the word will still be curly brace, okay. So that is also another limitation here when we do write program this way. There are two limitations here. One is this blank spaces. For that we'll have to process by reading line by line, whereas here this is again, this is due to the way we have done this, okay. So when I read curly braces, so it will not still be end of file, okay. So only after I do further read, see, so what happens is when I read curly brace, the pointer is next here, okay. So it will not say still end of file. When I try to read further, it will get end of file, but then we'll execute this cout once again, okay. But the word content would not have changed because there was end of file, okay. So it did not change. So the word content will be still the closing curly braces. So it will print it again. Okay. So we'll see how to overcome that. So one way to do is sorry. So you read first. You first read it before the end of file, okay. Or you can do a do while, okay. So you can, if you do while, this is solved automatically. Or you, the way you implement do while is you first read it, okay. So before checking for end of file. So this immediately solves this curly braces problem, okay. That's because the moment you hit end of file, you will also be outputting a value, okay. So at that iteration you want to avoid that. So that for that what you do is you read before, okay. So this has to read before, you output the value and then read, okay. So effect of this final read will be available here. So then there will not be second output of word, which is basically curly braces, okay. But still the loss of this tokenizing or separators, so the blanks, the new lines here, blank spaces, they will still be there, okay. So they can be overcome only if you use getLine, okay. So all these are completely suppressed. So this new line is suppressed, this new line is suppressed, everything is suppressed. So here this will be return 0, okay. So for that what you could do is, so there is this function called getLine, okay. So getLine is a function in the standard namespace. It basically takes a file, I mean file pointer, that is iStream, ifstream file pointer, and then a string object, okay. So when I say get line, it will read the first line, and okay, so this is what is shown is not completely correct, okay. So there's new lines, it's fine, okay. And that is how it will be, okay. So it will be reading line by line, but while outputting, so when I say get line, so the end of line, right, the new line character will not be read at, okay. We'll have to do it explicitly. So here what we did is, so when I say cout line, it outputs line by line. So in that case all blank spaces will come in, so this blank space will be preserved. So I file, where is that, yeah, so this blank space will be preserved here, okay. So blank spaces all will be preserved, but new line will still not be inserted, because while reading into line, when I say get line, the new line character will not be inserted in the string corresponding to line, okay. The string will contain the first line, which is hash include iostream dot whatever, iostream without dot, but the new line will not appear. Similarly, new line will not appear. So, but I am outputting it as it is without inserting the new line. So I'll have this, but the blank spaces will appear. Now all you do is, to get a new line, you put an endl here, okay. So then that will solve the problem, okay. So this solves the problem. You'll get the required output. So the output is essentially the same way as we expected, okay. So this is a kind of limitation. Like I said, getLine is helpful to suppress the functionality of C++ ignoring white spaces, okay. But even then, the end line or new line separator will not be inserted. So the line will not contain the new line separator. You will have to do it explicitly, okay. So these are the things that you need to keep in mind while processing files. Yeah, so this is something many of you would have seen, passing argument line, okay, or command line arguments, okay. So most of you, when you compile in Linux, you would have seen that your output file is a.out. You could change them. You might have already seen how to change the name of the file or how to get a different executable file name, not just by changing. While the compiling itself, you can redirect into something else, okay. So now if you want to have command line arguments, it's the same way as what is done in C, okay. So you have to have main with the two parameters. One is integer value, which basically says number of arguments, arg count. So number of argument will be 1, 2, 3 in this case if you have two additional arguments. So the first argument will be the file name itself, and sorry, then it will be a character string, okay. It will not be an object of string class, but it will be a character array, okay, or sorry, string array, okay. So argv, this basically indicates each is a string, so you have pointer to string, so pointer of pointers to characters, so it's basically two-dimensional array or array of strings, okay. So now what you can do is you can so argv0 always will contain this a.out, this file name. So argv1 is what we need to look for, the first one. The second parameter will be argv2, third will be argv3, and so on, okay. So assuming that you want to run a program where you want to specify what is the input file and what is the output file, this will be the code segment. You declare input file stream, let's say variable is ii file, with the string as a parameter. The string is this argv1. This will be argv2. So I declare output file stream, say OO file with the argv2, okay. So then this will be the procedure to read from the file which is the first whose name is the first parameter, and then write it into the second file. I mean into the file whose name is the second parameter, okay. So this is how the code segment will look like. It's essentially borrowed from what we have done, but this also demonstrates passing command line arguments to your C or C++ program. It's the same way as what is done in C. Sorry. Okay. Yeah, so this slide we used to demonstrate yet another stream that we didn't really discuss, okay. So you would have again seen the error stream, okay. So the errors, so see, for any program you have three standard streams, okay. So one is input stream, output stream, and then error stream. So error stream we generally don't use in our regular programs, okay. But you can imagine, say for example, if you are a programmer, say trying to implement some functionalities in Linux operating system. You don't know what is an, I mean, you haven't been taught operating system, but let's say, I mean, you know that operating system. Okay, so there is a question, I think, just a minute. Okay, so that, yeah, good. It's a good question. I don't know who asked the question. Yeah, Shiva Subramanian. Yeah. So when you declare off stream, right, the pointer will always start from the beginning, okay. But there is one thing. So when you open a file in off stream as an object for off stream, it's basically opening for output. So what it will does is it will erase the content, okay. So it will not, so you might remember this append mode and write modes, right, various write modes, replace and append modes, okay. The standard mode here will be, so if you don't include this, so you can actually have the second parameter here to describe the mode. If you don't specify the mode, what it will do is it will open the file and it will hold the start, the pointer will be to the beginning. So whatever you write to that file, it will replace the original content of the file. Okay, so that is something that we need. Yeah, so default overwrite. Okay, so by default it will overwrite. So this is a feature of almost all programming languages. When you process a file, the default feature is overwrite. If you want append, you will have to have a parameter, second parameter here, a mode parameter. Okay, yeah. Yeah, so coming back to the need for error stream. So you can just imagine, see, now most of you are familiar with this command prompt, right? So many of you would also know how to run processes in the background and so on. I believe so. If not, just do a Google search and try running your process in background. Okay. So when I say my command name, in the command prompt, if I type, let's say a.out with an ampersand, this will run my process in background. Okay. So there are also commands which will let the process being foreground and so on. I'll leave you to understand what it means by running a program in background and so on. Okay, so let's not discuss that. But I want to demonstrate the necessity for the error stream. Okay, so there could be multiple functions. So your program itself might be running another program. Okay, but that program might have terminated, but you wouldn't know if there was some error to be passed. Okay, so in here in this setup you are not really running, you're not into that scenario, but it could be that your processes are communicating. So processes are nothing but program under execution. Okay, so multiple programs might be communicating with each other. So one way to do that is through this error. So at some point, if you see that there is an error message, then what you do is you can just put it into the CR stream. Okay, so CR is an object of type error stream. Okay, it is again by default declared, and in most of the cases, in the standard usage, CR will be the same as cout. It will be pointing to the same as cout. So this message will come to you in the display. Okay, but in many cases you can redirect it to something else, some common stream between multiple programs which are running in parallel but in the background. Uh, in that case, you can use this stream to pass on that error information. So when the CR is non-empty, that means that there is some error in one of the programs that you are interested in or your program is interested in. So in the standard scenario, we don't really need that. Okay, so this part basically says if number of arguments is not 3, so this is 1, 2, 3, that means error. Okay, so the usage should be file, the command name followed by input file, output file. Okay, argv0 will be a.out, input file, output file. So this you might have encountered, right? If you run GCC without something, without anything, it will say usage. Okay. So yeah, it's not completely relevant for us, but I request you to read about CR, I mean the error stream, not just CR, the error stream. You must have seen the same thing in C as well. Like I said, it's useful when you have multiple programs. So your program want to communicate with something else, then it's really useful. Okay. Else by default, it's going to be the output stream, the standard output stream. Okay. So this is another, this just demonstrates another scenario. So in case if the file could not be opened, right, the status will be fail. The fail function will return true. Okay. So then in that case, you can also put something into the error string saying that the file could not be opened. So particularly, I mean, if you do GCC with some file name where the file name, the file with that file name does not exist, it will say file could not be opened, right? This is exactly the section of the code if GCC were implemented in C++. Okay. Yeah. Yeah. So we need to know something about formatting our outputs. Okay, something very similar to what we did in C as well. Okay. Uh, okay. Yeah. So, you might have already seen. So, okay, you can put strings, right? So, in double quotes, and you can output it whenever you like. Okay, so this will actually put whatever the content of name followed by the string, followed by roll number, followed by value of role, followed by the string, and so on. Okay, so you can, so just the way you would do in C, you can also use this feature to format your output. Okay. So here what it does is, so for example, I mean, there is a slightly different use of getLine here. Okay, so yeah, so here I think I don't know if it is visible to all of you. So getLine file was opened as data.txt. Okay, so as input file stream, and so it reads value into roll number, which is a string. Okay, so this is used as a separator. Okay, and similarly this is used as a separator, dot is used as a separator there. Okay, so when you output data, it will look like, so name with this whatever it is, yeah, 3 colons, followed by roll number, followed by 3 colons. Okay, so then this red data will be John Augustine until the yeah, so it will see this, it basically suppresses this colon, so it will have, so sorry, it's not until. Okay, so this is a character to be suppressed. Okay, so John Augustine CS12D001. By the way, John Augustine is one of our colleagues. Madhu is also one of our colleagues, and Rupesh is one who created the slides. Okay, so it will output John Augustine CS12D001, but then this separator will come here. So that is here, whatever. This is the separator. Okay. Okay, sorry. Yeah, sorry. So this will be the separator. Okay, so colon will be used as a separator. But one thing we need to note is the colon will not be read. So John Augustine will not have colon. So similarly, CS12D001 will not have the colon here. Okay, I'm sorry. Okay, so these 3 things, so 3 colons is something that is inserted by us. Okay, so name will be John Augustine. See, I actually, so another way to read, see, maybe I should make it a point. See, the reason we did this kind of, so I could have put, instead of colon, I could have put a comma, is basically reckoning that a name might have spaces. Okay, so if I had just read, so if I just say C in redirect to name, what I would have got is John. Okay, so then C into roll, what I would have got is Augustine. Okay, so that way there could have been a problem because C++ inherently suppresses, so C in inherently suppresses blank space. So one way to overcome is use the getLine command, but the getLine function, sorry, but the getLine function also, it's overloaded. It also takes 3 parameters where this is treated as a separator. So basically, instead of new line, this treats this colon as separator. Okay, it treats this colon as separator. It treats this colon as separator. Okay. Yeah, so that way name would be John Augustine, then CS12D001 will be roll number, marks will be 88. Okay. Yeah, so I request you to read about formatted output from any of the textbooks. I would suggest C++ primer. Okay, it has a very good treatment on this. I will, yeah, so I'll skip this portion now. Yeah. Okay, just request you to go through. I'm already out of time here. So there are a couple of things that I wanted to say before I end. Sorry. Okay, so these are the file modes. So in is input file, out is output, app is for append. So this is equivalent to so R, W and A in C. Okay. So ATE is at the end and trunc is truncate the file. Yeah, so this is something that we can ignore now, particularly if you want to read an executable file, right? This is the binary mode. Okay. Yeah. So before ending the lecture, so I request you to read string IO. Okay, it's very similar to IO on input and output stream as well as file input and output. Okay, so the class name is stream. Okay, so that is for corresponding to input iString stream and OString stream. I request you to read. So one good reference for it is C++ Primer by Lipman, Lajoie and Mo. Okay, I'll stop here. I'll stop the recording, but I'll be available for questions.